welcome to EC Electronics. Today's video we are going to discuss some questions, some tricky questions with resistors, which you can probably find in your competitive examinations. You will be facing these questions. These type of questions are very simple if you know the concept. So I'm going to give you some tricks to solve these questions with resistors, how to solve these questions really faster. Okay, so let us start with some simple questions first. Two resistors R1 and R2 give combined resistance of 4.5 ohm in series and 1 ohm in parallel. The resistances are option A 2 ohm 2.5 ohm, B 1 ohm 3.5 ohm, C 1.5 ohm 3 ohm, D 4 ohm 0.5 ohm. Now, this type of question is called the series and parallel type of question. That is, you will be given the value of series connection resistance and effective resistance and the parallel connection effective resistance. And you have to find the individual values of the two resistors. Okay, so that is a question. Now, how to solve this question, I'll tell you. So, what is the value being given? R1 and R2 gives a combined resistance of 4.5 in series, means you can write R1 plus R2 is equal to 4.5, right? So, series resistance means the sum. Now, in parallel, they give how much? 1 ohm, right? So, you can write the first equation as R1 plus R2 is equal to 4.5. That is your first equation, which is the series representation. Also, in parallel, it will give 1 ohm, means the direct relation I'm going to write R1 R2 by R1 plus R2 is equal to 1 ohm. 1 ohm. Okay, so this is your second relation. So these two things you can write from the question. Now in this second relation, R1 plus R2 is already known to you, right? See here, from the first equation you know that R1 plus R2 is equal to 4.5. So you can replace this R1 plus R2 by 4.5. So 4.5 ohms. So from this you can write R1 R2 as, so R1 R2 is actually 4.5 ohm, right? So R1 plus R2 is 4.5, R1 R2 is 4.5. Now if you go and substitute, that is if, sorry, this is R2. So R1 R2 is 4.5 and R1 plus R2 is again 4.5. Now from this relation you can do either take the value of R1 or R2 and substitute in the first equation. This will be your equation 2 or your relation 2. So from this relation 2 you can find the value of either of 1 and substitute in the first relation, and then you go and solving a second degree equation. Probably it is a lengthy process, right? So if you obtain this much, now you can look into your options. Okay, now from the option you have to find the correct option which gives a sum of 4.5 and a product of also 4.5. So it is very simple. So the sum is 4.5 and what is the product? Is it 4.5? 2 into 2.5 is not 4.5, right? So it is not the correct answer. Next, 1 ohm and 3.5. The sum is 4.5 but the product is not 4.5. So it is also wrong. So option A and option B are wrong options. Now for the option C, what is the sum? Sum is 3 plus 1.5 is 4.5. What is the product? 3 into 1.5 is also 4.5. So the correct answer is option C. And for the last option also, 4 plus 0.5 is 4.5 but the product is not 4.5. So the correct option here is C. Now this is called solving from your options. This is how you have to think quickly or think wisely. Rather than just going on solving the equation, as I said earlier, you can also solve an equation and you can find the value, but it is a very, very lengthy process. Here you are going to answer the question in minimum amount of time, means just look into your options rather than just wasting the time. Select the correct option, giving a sum of 4.5 and a product of 4.5. Okay, so the correct answer is option C is your correct answer. In the figure below, R3 is open circuited. The voltmeter reads dash. So, in order to answer this question, you should know the series connection of resistors. That is, when resistors are connected in series, means whenever it is connected to another voltage source, what will happen? The voltage will get equally divided among these resistors according to the resistance value. What will happen if an open circuit is created in between? Okay, so if an open circuit is created in between, you should know that the voltage will entirely appear in between the open circuit. That is the case. So when R3 is removed, this entire voltage what is being applied will be coming as a voltage in between the open terminals. Okay, so let this be V volt. The voltage is V volt itself. Okay, so here if R3 is open circuited, here there is a 250 volt applied, right? So the 250 volt will entirely come in this open circuit, and the value of the voltmeter reading is equal to option D, which is 250 volt is your voltmeter reading. This is a very simple thing. You should understand this concept. Also, if let us consider that it is not open circuited, right? Now all the values of resistors are identical, 10 ohm, 10 ohm, 10 ohm and 10 ohm, right? So all the values of resistors are identical, and hence the voltage will get equally divided between these resistors. Since the resistors are identical, the 250 volt will get equally divided. 250 by 4 will be the value of each of these resistors. Okay, so the voltage is equally divided in the case of identical resistors. And if there is an open circuit, means the 250 volt will entirely appear in between the open circuit terminals. And if you connect a voltmeter, means the reading of the voltmeter is 250 volts. This is another type of question you can face in your examination. Here the correct answer is D, which is 250 volt is your correct answer. Next question that we are going to discuss today is this. 12 1 ohm resistances are used as edges to form a cube. I think most of you have seen this type of question, that is forming a cube with resistance in all the edges type of question. So this cube actually has some properties, and due to that we will obtain the value of this question anyway. Let's read the question first. The resistance between the two diagonally opposite corners of the cube is dash. That is, we need to find the resistance between two diagonally opposite points of the cube. Actually, once you understand this question, the type of question or the pattern of the question will be same. Only the value of the resistance may be different. So if you know this question, means you can answer any this type of question. Okay, so I've drawn a cube with as much as possible with my drawing skills. Okay, I hope this looks similar to that of a cube. Okay, so this is a cube, and I've not drawn resistance because it looks make the figure very crowdy. So this is the cube, and we need to find the value of resistance between two diagonally opposite points. Means if you're taking a point here, this is your point, let this be A. Diagonally opposite point will be, I'm not drawing dotted lines, this is your diagonally opposite point, which is B. Okay, now this diagonally opposite points, what is the value of equivalent resistance between these 2 points we need to find. Okay, so how to actually find the value of resistance between these 2 points? We have to first consider the point A. See, this is your A. Now this A is being connected with 3 branches. I'll draw it separately here. Okay, I'll use a different color. See, this A is having this branch, and this branch, right? So this A is having these 3 branches connected to form actually A. And if you take this point, that is this top corners, 2 resistances connected to A, and these point and this point, I'll mark this point as P and this one also P. Now due to the property of this cube, that is all the resistors connected to all the edges are having equivalent value or equal values. So due to that, this point P and this point P is having equal voltage. So there is no current flow between these P, that is these 2 P points. Okay, due to the value of same voltage or potential difference is same, so there is no current flow. So we can consider, if you take this resistor, I'm going to call this as X and this is Y. So this X resistor and this Y resistor are connected to same potential points, and hence we can consider X and Y to be in parallel connection. Again, in turn, if you see this point also, if you take this point also connected to the next resistor, let that be Z. Okay, and that Z is also having potential of P. Okay, so it is in turn connected in parallel connection with the X, Y and with, that is with X and Y. Okay, so if you take the point A, the A is connected with the resistors X, Y and Z. Okay, so this X, Y and Z are one point connected to A, that is the terminals of X, Y and Z resistors are connected to one point A, and another point is connected to three same potential regions, and hence we can consider X, Y and Z to be in parallel connection. This is the theory of this cube formed by resistors. Okay, so we can consider X, Y and Z connected in parallel connection, right? So what will be the equivalent value of resistance here? These three resistors are in parallel connection, so it will be equal to, all the resistors are having value equal to X equal to Y equal to Z equal to 1. Okay, so the value of equivalent resistance equal to 1 by 3 is the equivalent resistance of these three resistors. Okay, so now we got the resistance equivalence of these three. Okay, now let us consider the next point B. Okay, I'm going to consider the next point as B, and I'm going to mark, that is again this B is also connected with three edges or three edges. Okay, so I'm going to call, I will remove this P. Okay, so this B point is connected with this branch and also this branch. Okay, so B is connected with one point here and one point there. We'll call the resistors as P, Q and R. So if you consider the case of this P, Q and R, this will be similar to that of X, Y, Z. So the resistors P, Q and R are connected. I'll draw it once again. So this P, Q and R, P, Q and R are one point connected to B, and another points are connected to equal potential regions. Let that be alpha, this one, and here alpha and alpha. So these three resistors are one point connected to B, another point or the other terminals are connected to the same potential regions, and this potential similarity is due to the formation of a cube with all equal values of resistors. Okay, so again here also what will be the equivalent resistance? It will be equal to 1 by 3, because all resistors P equal to Q equal to R equal to 1. So the equivalent resistance is equal to 1 by 3 for the point B. Okay, now we have considered all the resistors connected to A and B. Now there are other resistors in the cube which we have not yet considered. Now let us consider that. Okay, so what are the other resistors now? There is one resistor in this. I have actually not drawn resistors in this branches. So while you see this question or while you read this question, you have to assume a cube with all resistors in its branches or edges. Okay, so now we have to consider the left out resistors. Okay, so the left out resistors are this one here, and here, here and here. Okay, and here also. So how many resistors are there? Consider all the resistors marked with color green. 1, 2, 3, 4, 5 and 6. So there are 6 resistors. Now again, if you consider this top resistor, I'll call them by numbers. Okay, 1, 2, 3, 4, 5 and 6. Okay. Now consider the resistor 1 and 2. These 1 and 2 are connected in which connection? Again, they go to the same potential point. So one point is connected to this region and another point connected to the same potential region. So they are in which connection? So 1 and 2 are in parallel connection. So similarly, the resistors 3, 4, 5 and 6. I've just marked with numbers so that it is easy to find out. Okay, so 1, 2, 3, 4, 5 and 6 are connected in parallel connection. So these resistors all are connected in parallel connection, and what will be the equivalent resistance? It is equal to 1 by 6. Okay, so now we have found out what is the resistance of point A due to XYZ, what is the resistance at point B due to PQ and R, and also what is the equivalent value of resistance due to these 1, 2, 3, 4 and 5, 1, 2, 3 up to 6. Okay, so we have obtained the value of resistances as, that is, it will, and if you open this this branches or this edges of the cube, it will look like this. I'll draw that for you. It will be equal to, see, there is an X, Y, Z, and it is having equivalent resistance of 1 by 3. Here at the point B, there is P, Q and R. P, Q and R. Also that resistance equivalent is 1 by 3. Now in the middle there is 6 resistors again connected in parallel. 1, 2, 3, 4, 5 and 6. So, and if you join this, it forms a series connection. Okay, so join the points with XYZ equivalents, then PQR equivalents, then with that of 1 up to 6 resistors equivalent, it forms a series connection. Okay, now this is 1 by 6. So this is how you will obtain if you open out your cube. Okay, so this is 1, 2, 3, 4, 5 and 6. Now these are the resistors XYZ connected to same potential region. So in parallel form, PQR connected into same potential region because they are in parallel connection. And these 1 to 6 resistors are connected in parallel connection. And these 3 forms a series connection. So this is the theory for a resistance cube. So this question is called the resistance cube question. Okay, so what is the equivalent value of resistance? It is equal to 1 by 3 plus 1 by 6 plus 1 by 3, which is equal to 5 by 6 is your answer. Now, just try to understand the theory question of this, or the theory part of this resistance cube. In the question, they will be replacing the resistance value with either 2 or 3 or any numbers. Just if you know this theory portion, you can answer any of this question. Otherwise, if you go on thinking how to solve this question, I'm pretty sure that you won't be able to solve it without understanding the concept. Okay, so this concept you have to understand. This figure is the thing which you have to remember in your mind, that how to solve a resistance cube question. That is, if you open out the resistance cube, you will get a figure something similar to this. Okay, so the correct answer for this question is 5 by 6. Okay, so option A is your correct answer, which is 5 by 6. I hope this is clear. So this is one typical question you can face in your competitive exam. This question is called the resistance cube question. And the property of this cube is that you can only form the cube with equal resistors. Okay. The next question that we are going to discuss today is this. For the circuit shown below, the equivalent resistance is dash. Okay, so this is a circuit having three 12 ohm resistors, right? How will be the connection? Whether this looks like that of series connection, right? So what is actually the equivalent resistance? Even though the circuit looks like series connection, this is not actually series connection. If you see from this edge, there is a connection to the second resistor's edge. Then from the middle of these two resistors, there is one connection to this extreme end. And if you pull out this connection and also this connection, if you pull down, you can actually form a connection like this. This is actually the connection. Because of these two wires, the connection, that is a series connection, is actually now formed as parallel. So don't confuse with the connection as series. It is not a series connection, because if you see such a question, there are chances that you can write the answer as 12 plus 12 plus 12, which is equal to 36. No, it is not a 36, because this, if you pull out this wire and this wire down, you will get a parallel connection of 12 ohm, 12 ohm and 12 ohm. So what is the equivalent resistance? It is equal to 12 by 3, which is equal to 4 ohm is your equivalent resistance. Now, how to understand whether this is a series connection or a parallel connection? I'll tell you. See, if you see the first resistance, look for the terminals of the resistors. This terminal of the first 12 ohm and the second 12 ohm is connected together, right? Also, look for this end terminal. This terminal is connected to the end terminal of this 12 ohm. So, from that, it is clear that both the terminals of the two 12 ohms are now connected together. That is, this 12 ohm and this 12 ohm. Both these terminals are connected together, and hence it forms a parallel connection. Also, with this two resistors, both the terminals are connected together here, and here also the next terminals are connected together. So, this is how you have to check whether the resistors are in series or parallel connection. That is, if the resistors, both the terminals are connected together, means they are in parallel connection. Otherwise, there is one terminal connected together and the next terminal is connected to some other point, means it is a series connection. Okay. So, this is how you have to check. So, the correct answer here is option C, which is 4 ohm is your correct answer. Next question. Okay. How are 500 ohm resistance connected so that to give an effective resistance of 750 ohm? Okay, so if you see such a question, that is, you have to obtain some value of some resistance with some other resistance, that is by series, parallel connection or combination of series and parallel. You have to first look that whether the value to obtain is greater than that or lesser than that. If the value to be obtained is greater, that is 750 is greater than 500, right? So, most probably there can be a series connection in between, or there can be a complete series connection, because only if the resistors are connected in series, the effective resistance increases. If the resistors are connected in parallel, the effective resistance decreases, right? So, here is 750 we want to get as effective. We only have 500 resistors. 500 ohm resistors we have. So, there can be a series connection. Now, we have 500 resistors and we need to get a 750 value, right? So, consider that this 750 is split. See, we will split the 750 in such a way that we probably can get a series connection, right? So, we will split it as 500, and what is the left out? Left out is a 500, right? Sorry, left out is a 250, right? So, if you divide 750, you will get 750 as 500 plus 250, right? Since why I am splitting it as 500 plus 250 means I have a 500 resistor in my hand, right? So, I am going to make a combination of 500 resistors, 500 ohm resistors to get a 750. So, First, I'll split the 750 as 500 plus remaining, what is that? 750 minus 500, which is equal to 250. Now, think that how can you get a 500 plus 250? We need to get a 500 plus 250. How will you get it? If you connect two resistors of 500 in parallel connection, parallel connection means you will get a 250, right? And plus a 500 means plus a series 500 resistor. So this is actually your required combination. This is how you have to think. Okay, so always keep this thing in mind that if you want to get an effective value which is greater than your present value of resistors which is having in your hand, means it can have a series resistance combination or it will be a series connection of those resistors. Now look for the value to be obtained as effective. Can you split it as divisions of your resistor value? Or can you split it as a combination of the resistor value plus some other value? If you can do it, you can form a combination of series plus parallel maybe. Okay, so here it is a 750. So I am dividing it as 500 plus 250. So 250 is formed by two 500 ohm resistors connected in parallel. So you will get a parallel combination of two 500 ohm plus a series combination or a series connection. So you will get a 500 plus 250. So this is how you will have to solve it. Now I will read out the options once again. Sorry, I will read out the options once for you. Option A is 3 500 ohm in parallel. Will that be the case? No. 500 by 3 is not equal to 750. So it is not your correct answer. Option B is 3 500 ohm in series. No. Because 500 plus 500 plus 500 is 1500. So it is not the correct answer. Option C is 2 500 ohm in parallel. No, it will give you only a 250. Option D is 2 500 in parallel, 1 in series, which is your correct answer. Now, the correct answer is that 2 500 ohm resistors are in parallel, and another 500 ohm is connected in series to that combination. Okay, so the correct answer is option D is your correct answer. So these are some type of questions of resistors which you can find in your competitive examination. So I'm giving you this trick that if you found such a question or such type of a question, you have to think it this way. Okay, I also think that the resistance cube question is clear for you because that is one of the new concepts which I'm introducing in any of my videos. Okay, so the resistance cube is also very easy to solve. You know the concept. Otherwise, you will be spending a lot of time thinking of how to solve that question. Okay, so I hope this video was useful for your preparation if you're preparing for any of the competitive examinations of electronics, and also for the GATE exam if you're preparing, it is useful. And if you found this video useful, please do give it a thumbs up and also share this video with all your friends. And if you want to see more videos, please do subscribe to the channel and please do tell your friends to subscribe to the channel. Okay, so that's it. Thanks for watching and keep on watching.